All right, so we're given three matrices here, A, B, and C. They're all 2 by 2 square matrices. And we're asked to solve the matrix equation AX plus B equals C for matrix X. Okay, so think if we were just solving this algebraically and there were no matrices involved, I would be subtracting B from both sides. All right, and then I would divide both sides by A, right? Okay, now think about that though. Have we talked about division with matrices? No, we have not. And we're going to instead look at this, instead of dividing by matrix A, we're going to multiply by the multiplicative inverse of matrix A. Okay? So that's how we're going to want to approach this. All right, so let's back up here. Let me substitute the matrices in. All right, so first thing we're going to do is subtract over matrix B. And that's going to lead me to the following. All right, so -5 minus 3 would be -8. 3 minus -1 would be 4. -5 minus -2 would be -3. And 1 minus 1 would be 0. All right, and then again, to get X alone here, I don't really have a concept of matrix division. So what I'm going to do instead is multiply both sides by the inverse of this matrix. So I'm going to use this notation. All right, now again, we know that a matrix multiplied by its inverse should yield the identity matrix. So these two right here should produce this matrix. All right, and then I'm actually going to find the inverse of that matrix now. So I need 1 over the determinant of the original matrix that was in front of X there. So if I take that product, -10, minus that product, -15, -10 minus -15 would be +5. Then I'm going to switch the positions of the 5 and the -2. The 5 gets negated, and the -3 gets negated. All right, now the identity matrix that's in green there, if you multiply it by matrix X, you're just going to get matrix X, right? Okay, let's save the scalar of 1/5 for the end here. And then I'll multiply the red matrix by the blue matrix there. It's going to create a 2 by 2. All right, so first row, first column, I'd get negative 40 plus 15. That's going to be negative 25. First row with second column, you'll get 20 plus 0, or 20. Second row, first column, negative 24 plus negative, actually plus 6 will give me negative 18. And then second row, second column will give me a 12. Put it there. All right, now multiply through by the scalar. Negative 25 times 1/5 is negative 5. 20 times 1/5 is 4. Negative 18 times 1/5 is negative 18/5. And 12 times 1/5 is 12/5. There's our solution. Questions there? All right. Now let's use an inverse of a matrix to solve a system. Okay? So I got a 2x2 system here, and what we're going to do is create a matrix equation from it and then solve that system using inverse matrices. All right? So the matrix equation, in order to create it, you want your system to be in standard form, which both equations already are. It will be made up of 3 matrices. So I'll call the first one the coefficient matrix A. It would have elements 5, 3, 4, and 7. Okay, I'm going to multiply that by the variable matrix, which would be a 2x1, 2 rows, 1 column, where the top element is X, the bottom element is Y. Now let's pause there and make sure we understand how this works with the original system. So think, if I've got a 2x2 with a 2x1, I have the inner dimensions are equal, so the product will be defined, and it will create a 2x1, right? Now, when I go after the first row, first column element, I would go 5 and 3 with X and Y. So the 5 would multiply the X, and the 3 would multiply the Y, and then we would add those together. So see how that's just going to take me back to the first equation. All right, and then similarly, second row with the first column, I do 4 times X, which is 4X, added with 7 times Y, which would give me the second equation. Okay. All right, so let me back up here. All right, now we're going to set this all equal to a constant matrix. 13, negative 8. So think the matrix that I just would get by multiplying these two together, if it's equal to the constant matrix of 13 and negative 8, again, it's just going to take you back to the system. All right, so the way we'll solve this, we want to get the variable matrix by itself. So we are going to multiply both sides by the inverse of matrix A. All right, so just like on the last problem, we know that when we multiply these two matrices together, since they're inverses, we're going to get that identity matrix. carry down the variable matrix. All right, now let me actually find the inverse of matrix A. So that's going to equal 1 over the determinant of A. So 5 times 7 is 35. 35 minus 12 gives me 23. And then we'll have to switch the positions of the 7 and the 5, negate -3 and -4 from the original matrix A. And I copied this wrong. This should be 13 and -8 there. Sorry. All right, now, I didn't really talk about this on the last problem because we were just dealing with all 2x2 square matrices. Here in this particular problem, though, it's very important that I have this set up to where the inverse matrix that's in red here is before the constant matrix in blue. If I put it the other way, the product is not defined, right? So here I've got this would be a 2x2 with a 2x1. Again, inner dimensions are the same, right? And I'll get a 2x1 out of this. Had I flipped this and wrote it like this, now I'd have a 2x1 with a 2x2. That product would not be defined. So just make sure you're setting your work up correctly so that the product will be possible. Okay? All right, now identity matrix in green times the variable matrix is just going to create the variable matrix. Save the scalar of 1 over 23 for the end. Okay, a 2x1 times a 2x2 times a 2x1 is going to create a 2x1. So 7 times 113, or 7 times 13, added with -3 times -8 is going to give you 115. And then -4 times 13, added with 5 times -8, it's going to give you -92. And this actually works out nicely. Once you multiply through by the scalar, you get 1/23 of 115 is 5. 1/23 of -92 is -4. Notice I have two matrices together equal to each other with the same dimensions. That means their corresponding elements are equal. X is 5, Y is -4. And of course, I can state my solution as an ordered pair.